Welcome to the lecture. Nice to see you all, and nice that so many people this semester. I think some people might still be coming, but let's start anyway, because most of us, I think, will have something after this lecture. So we start in time and we try to finish in time. So welcome to the Introduction to the Ethics of AI, which is this lecture every Tuesday from 2 to 4 here in this nice room. As most of you know, this is a compulsory lecture now in the COXI study program. Who is in the bachelor? Whoa. Who is in the master? A few. And who is in another subject, like who does not study cognitive science? Cool. There are quite a few who don't study cognitive science, and they are explicitly welcome, so it's an open lecture for everybody, including even external people or people who are not here in Osnabrück. That's all fine. Yes, welcome to also to the Ethics and Critical Theories of AI research group. So this is the introductory lecture by this research group. We have the Ethics and Critical Theories of AI research group at the Institute of Cognitive Science. Our mission is a contemporary philosophy or critical philosophy of the digital age, and we work a lot on topics such as power-aware ethics of AI. You will hear something about that in this lecture, I guess. AI regulation, data protection, critical philosophy of technology in general, and so on. And this is a quite outdated group photo. If you want to find out more about us and our work, also our teaching, there are these websites on which we collect all the information about our project, research, and so on. And also you can turn to our publications. But in this lecture, you will basically get a digestion of all of this handed week by week to you. So maybe you just sit back and listen. Yeah, this is the team for this lecture. I'm Rainer Mühlhoff, here a professor of ethics and critical theories of AI at the Institute of Cognitive Science. My pronouns are they, he, or she, as you see fit. In the lecture, we also have 3 student tutors, which are Sean, Lei, and Frida. I think Frida is here. The others are probably online. And this is basically the team doing this lecture and the weekly discussion groups. I will explain about the weekly discussion groups in a minute. And yes, maybe today I want to start with some Augur stuff, and I try to be quick with the Augur stuff, because on the one hand, I wrote it all in this email I sent out to you yesterday. I'm not sure who saw the email, because I had some questions today by students that showed me that maybe the email did not arrive, or not everybody of you got the email, but it is also in the forum on StudIP with some general information. But you can also turn to the website of the lecture. And I will walk you through this now step by step, so that I hope I could anticipate most of the questions. Good, then let's turn to the content introduction. Yeah, ethics of AI, why ethics? I'm not sure. I mean, maybe you are here doing COXI or whatever to learn AI and not doubting AI or criticizing AI or ethicizing AI. As it turned out, over the last years, if you look into the news, into politics, AI is growing into a technology that is of vast impact at global scale. And part of this is also why professorships such as this one here were created years ago, 5 years ago. So there is now, or has been for at least 5 to 10 years, the growing demand in society for and also an ethical questioning or scrutiny of emerging technologies such as AI. I understand AI in a broader sense, and what we are doing here is actually something that should be done for other emerging technologies as well, and especially for digitalization in general. So you will find that some of the things that we learn here are more about the impact of technology on society, and sometimes they are more specific about the impact of AI technologies on society. AI is now everywhere in the public discourse, right? Like, unlike 10 years ago, when this was still a slightly more nerdy debate, now everybody is talking about AI. And if you observe the public discourse, you will also see that there is even a certain imagery or imagination of AI, or a certain way that people envision AI or talk about AI, what people think about AI. And that's not necessarily what AI really is technologically or maybe even politically. Some tropes from the public discourse, some things, some images that pop up again and again. Here, this is the most maybe the most old-fashioned one in the recent AI summer: self-driving cars. Before ChatGPT, everybody was talking only about self-driving cars. When you say, I do ethics of AI, then people would come up to you and say, so you're researching about self-driving cars and who they should kill, either the crowd of kids or the crowd of old people. Yeah, that's what I do. As you will see in the lecture, it's not, but that was kind of this imaginary that got stuck. It was also very impressive in the public discourse when AI mastered big board games such as chess or more recently Go. That also sparked a huge public interest in AI and certainly shaped the public imaginary of AI. Coming up with such images here and like robots in thinker pose. And I think the definite breakthrough of the public going crazy about AI was certainly ChatGPT 2 years ago, which kind of even shifted a little bit. Since ChatGPT, I've less been asked about self-driving cars and which bunch of people they should drive over. So attention really shifted, if you will. That was a relief in some way. But also this year, like more robotic style stuff. Robots or AI in elderly care, at school, AI teachers, service robots. That's maybe 4 tropes making up the public discourse of AI. And if you look at this from a humanities scholarship perspective, and we will be doing humanities scholarship here, Geisteswissenschaften. We will not be technical, it is philosophy. If you look at this from a humanities scholarship perspective, you will find that all these imaginaries of AI have certain features in common, certain maybe hidden assumptions or tacit understandings of AI that are often implicit. If you want to visualize it, this is the best visualization I could come up with. I would say that the popular imaginary of AI looks a little bit like this. It looks like a digital or even electronic simulation of the human brain or the human mind. Who knows? And is that the same? Whatever. So I would say that the public imaginations of AI figure AI a little bit like this. It is kind of the electronization or digitalization of what happens in the brain or in the skull. Let's say in the skull. And that comes with certain assumptions. The one is localization. AI is hiddenly assumed to be inside the autonomous machine. AI is assumed to be inside the self-driving car, inside my phone if I talk to Siri, inside the robot that greets me or that teaches me math, even inside the chatbot, whoever that chatbot is. So there is this imagination that it is locally circumscribed, that it is contained. And you interact with it through an external surface. Much like you do with human intelligence. You always envision human intelligence to be localized within the skull. Yeah, only few people envision human intelligence as something like, for instance, distributed or crowdsourced or something that's not localized. It's your intelligence, and your intelligence is in here. Yeah, that is the assumption. It's not a true assumption, but it is an assumption that shapes the imagination about AI. The next thing is anthropomorphization. It is a dominant aspect of the popular discourse on AI that we anthropomorphize AI systems. And that means that you attribute human features to AI apparatuses. Yeah, it starts already from the language. You say that the system learns, that the system speaks to me, that the system teaches me math. That puts the AI system in the active role of the sentence, right? It's always the subject in the sentence, and it gets an active verb, and a verb that usually describes human activities. The anthropomorphization also continues when you ascribe, for instance, feelings to the system, or awareness, or even intelligence. Maybe the attribution of intelligence is also something that is an attribution of human skills to a technical system. So a lot about even the concept of AI is a projection. Next week we will talk more closely about this, why there's actually an inherent projective structure in the notion of AI. Yeah? You will have a hard time talking about AI without buying into certain projective features, like that you project human features on the technical system. There's also an inherent aspect of futurism in the debate of AI. Yeah, there is hardly a debate of AI that is not in some way futuristic, be it that AI will solve all our societal problems, be it that AI will be an existential risk. Yeah, that's this doomsday discourses about AI. Be it that we should not miss out on AI, that we should not hinder innovation by, for instance, regulating AI. Be it that you should invest in AI technology to prosper as a society or as an industry in the future. Be it that you study AI because you think that this is something that will give you a great professional life, or that is a nice field to get engaged in for the next 20 years. Yeah, there is this huge futuristic aspect about AI. Debating AI or arguing about AI is often implicitly or explicitly arguing about the future. Your future, society's future, the planet's future, and so on. And there is this implicit or explicit aspect of solutionism in the public AI debate. Solutionism, it's actually part of what we will analyze as AI ideologies in this lecture. Solutionism is the idea that you can fix political or social problems with technology. Yeah, for instance, scarcity of teachers at school can be fixed by building AI systems for schools. That would be a solutionist argument, because the scarcity of teachers at school is certainly a political and social product, a product of political mismanagement, of maybe the social image of the teacher job, maybe of the underpayment of the teacher job, and so on. And the idea is we can solve it with technology. The idea to solve social problems with technology is vast and abundant in AI, and it is actually driving quite a part of AI investments. And Yevgeny Morozov called it solutionism even already in 2013, as we will debate here in the lecture. Yeah, these are maybe 4 general framings of AI in public debates that you could remember and that we will be dealing with here in the lecture. And what actually I want to, maybe if I am to summarize the lecture in one image or in one slide or in a nutshell, I think the message is, maybe the philosophical methodology that I will adopt in this lecture is that we should strategically, so to enable a responsible and critical debate, of AI technology, we should strategically envision AI not like this, but more like this. So not as the digitalization of the human brain, and not as simulated neural networks or networks of whatever kind that resemble what is in the skull, but it's more information networks that enmesh many people, maybe even all people in society, or nearly all people in society. That is the general approach I try to adapt here. And this is actually the idea to adopt a slight perspective shift that will open up certain insights. It doesn't say that the image on the left hand is like outright wrong. It's more, the idea is more that by shifting the perspective on AI slightly to a more distributed and socio-technical perspective, as you will find that we will be calling it, by shifting the perspective that way, you can make other aspects about AI, and especially about the entanglement of AI and society, more visible and debatable and even criticizable, if you say, if there's such a word. So it is more an invitation than it is an invitation to look at AI in this paradigm that I will explain to you in the rest of the lecture. And as you will see, that paradigm comes with the idea that we need to talk about AI differently to open up certain questions of responsibility, but also that we need to talk about different AI. Yeah, that, for instance, by the choice of examples that we use to explain AI, to talk about AI, to reflect about the societal impact of AI, the choice of examples actually has a huge impact on what you will be able to say about AI and the societal impact of AI. If you pick the wrong examples, you will get the boring questions, boring ethical questions, as in the trolley problems for self-driving cars. It is actually a very boring question because it is a boring example. So conceptually, yeah, as you see, this goes on two levels, on the conceptual level and on the kind of material or phenomenological level. Yeah, which phenomena will we be addressing? And conceptually, it means that in this lecture we will analyze AI systems as socio-technical systems, so as systems that do not consist only of computers or programming code or server farms, no, but also of humans. And actually, I come with the proposition that nearly all of AI, especially the AI that is commercially relevant, so the AI that is backed by huge investment and market capitalization, is always human socio-technical systems. And this, on the phenomenological level, so concerning the choice of examples, we will look at present and not so much as futuristic examples of AI. Yeah, the idea is AI is already there and has been for at least 10 years, and it has huge societal impact. And I would say that the huge majority of people on Earth is confronted implicitly by the impacts of AI systems, but this is usually not the examples that we debate or that we depict when we write newspaper articles about AI or when we hear political debates about AI. And here, just to give you some, maybe 4 examples or categories of examples, impactful everyday examples of AI. Risk scoring, including credit scoring, is a huge business that has always been at the forefront of developing and using AI, and it has huge impact on billions of individuals worldwide. Yeah. Generative AI, especially when it comes to images, videos, text, and its impact on public debate, so on political discourses, voting behavior, even the erosion of democracies, as you can easily observe during this semester when you look at the US. This is maybe, for some, this targeted advertising is the most boring example. Still, it is, by market capitalization, the most important application field of AI technology. And that's why I will try my best to to deliver to you in this lecture, this is even a hugely societally impactful example. Yeah, it is not only about, then I see this ad and not that ad. What's the matter? I will try to tell you that there is something about it that matters hugely. And maybe to bring something that is less obvious, or I'm not sure, at least less debated and less well known, a majority of hiring processes and selection processes, for jobs, for places in study programs, and so on, even like, how would you say that, Altenheim in English, like the place where you go when you're old and sick. Even the places, the allocation of places there, a majority of all this is today driven by AI systems that make, or at least shortlist applicants for jobs, elderly care space, or study programs. And this is a very hidden, like non-visible form of AI, because rarely you are told that the AI system said you will not be hired. Actually, what all of these examples have in common are 4 things, I would say. And the 4 things are the things the points that were written in the one slide. So they are non-localized examples of AI. Yeah? The AI systems in these examples are not localized in the head of an artificial humanoid android, robot or something, or inside a self-driving car. They are networked systems. They live in server farms or even socio-technical systems. They cannot be localized easily. They are not futuristic. They are real now. They are not easily anthropomorphic. Yeah, it's hard to attribute human features to these systems. And what was the 4th? Solutionist. Yeah, okay. Often they are actually sold as solutions to problems. So they are examples of solutionism in one way or the other. That might be up to debate. Good. So I wanted to tell you that I will try to shift the perspective conceptually, but also in terms of examples. This is kind of maybe the indication of examples I have in mind. This is not the only examples, don't worry, just to give you some. And the conceptual paradigm shift needs a little bit more explanation. So I told you already that it will be about looking at AI systems as socio-technical systems, always with the question mark, yeah? All AI systems are to some extent or another socio-technical systems. Maybe some are less and maybe some are more. But you will be surprised how many AI systems are socio-technical systems that you so far thought are not. In this perspective, I call it human-aided AI. So the idea is human cognitive labor or human cognitive skills are a vital part of these AI systems. And I will explain to you this paradigm of looking at AI systems in the next section of the lecture. Yeah, to explain that to you, let's do a little historical excursion, going far back in history to the year 2006. I don't know who knows this guy, but no lecture about the history of AI. No lecture about AI without mentioning this guy, Louis von Ahn. Louis von Ahn in 2006 was a PhD student at the Carnegie Mellon University in the United States. And his dissertation project had the nice title, Human Computation. And I'm quoting here from a video where he presents his dissertation at a Google Tech Talk. So he was invited by Google afterwards to present the results. I'm quoting from that video. He says that, in that video, he says, yeah, it was the founding or initial idea of his PhD project that there are so many wasted human cycles every day on Earth. For instance, 9 billion human hours of solitaire were played in 2003. I'm not sure you know solitaire. This is a very stupid desktop game on Windows computers. Probably, I'm not sure if this is still up to date, But in 2003 it was. People were playing this offline game and wasting their brain cycles. Yeah, it is an allusion to processing cycles from the computer language. And he says, yeah, there are so many people just wasting their time with computer games, for instance. And then he says, in my PhD project, I am going to consider all of humanity as an extremely advanced, large-scale distributed processing unit. And the idea was to harness the wasted human cycles, human brain capacity, to solve computational problems that were, as of then, hard to solve. For instance, image recognition, natural language processing, and all the problems that you can already anticipate have in the meantime be solved. And one sub-project of his PhD project, for instance, was this. In 2003, he, together with his colleague Laura Dabish, developed the now very famous ESP game. It's a simple browser game. So in the Netscape web browser of the early 2000s, you could play it. And it resembles a little bit the Taboo game, yeah, this popular party game, Taboo. So you get paired with another random player by the server. Yeah, it's a browser game, so you get paired to a random other player. And the idea is that you don't know that other player and that you don't have any other communication channel to that other player. And both players get shown an image at the same time. And the idea is that you have to type the same, there is this text box here, yeah, this is the text box. And the idea is that you have to type the same keyword, as your play partner. And if you do so, and the quicker you come up with the same word, you get points. You both get more points the quicker you come up with the same word. So the idea is that you will type descriptive keywords of the image that you see. And there is even a list of taboo words. So words that you must not type. And yeah, after going for a couple of similar words, then both players see the next image, and so you can play at forever and earn points the quicker you type the same word as your unknown play partner. If you think about it a little bit, of course, it is a nice idea to get accurate labels for the images, right? Because you are incentivized to think, okay, what is the most obvious label that my play partner would come up with to describe the image, minus the taboo words. So you are incentivized to think hard of what is most standing out about the image, and the play partner is incentivized to do the same. And so you are likely to come up with the most significant keywords describing the image. And running that game on a database of images with a couple of million players allows you to actually obtain very accurate labels, lists of labels for the image. And labels, like for instance, keywords that you have recorded from 20 play sessions of 20 different pairs of players, that then you can put them as taboo words so that you learn the next word. Yeah, as the system will then learn the next word once you have sufficiently many play partners agreeing on a certain label. Yeah, that was done as an idea to obtain labeled image databases, which are, as you know, what you need if you want to use machine learning to train image recognition networks, and which are the scarce, or were at that time, the scarce resource, hindering us or them from building such systems. So the idea here was, we need humans be able to solve that computational problem of image recognition. And without them, we will not solve the problem, because we will not write a computer program that comes up with image properties like in a semantic style, as we tried in the 80s. Yeah, in the 1980s, people tried to do symbolic AI for image recognition. So if it has two eyes, if there are eyes in the image, and if the eyes are two, then it could be an animal. And then if it has a nose, so yeah, that's how you would do it with symbolic AI, and that did not work out well. So the idea in the 2000s was to use it, to do it with machine learning. And for machine learning, you need millions of training data items. And the training data items you needed to obtain. Either you pay people, or, as he boasts in his talk, you come up with a clever system that would even make people pay you to play that game, because that game became viral. It attracted millions of players within months. And as he tells Google in 2006, when he gives his Google Tech talk about that project, he could label the whole cache of the Google image search within 6 months with that game. And that was a time when Google image search would only find results by file name. So when you Google for dog, you would obtain images that are named dog.jpg, or where the dog is mentioned in the caption of the image, in the HTML caption, or in the surrounding text, but it could not look into the images. Google image at that time, yeah? Google image search at that time. So that was really something novel. This game was then also acquired or licensed by Google and became re-implemented as the Google Image Labeler online game, which was played by millions of people and which helped Google to obtain high-quality labels of the whole image search cache within 6 months in the early 2000s. Louis von Ahn, who stayed a researcher, even abstracted this whole principle and came up with this concept of games with a purpose. Yeah, gamification, this is actually just an example of gamification as we call it today, right? And the idea is games with a purpose are kind of the gamey side of AI problems. You have an AI problem, you need data, you want to obtain the data for free by real human users, so you need to turn your AI problem into something that users want to do, to give you the data, and so you turn it into a game, and then this is a game with a purpose. Nice concept. Let's jump by 10 years in our historical excursion. 10 years later, to name another guy, I'm sorry it's only guys, I guess that speaks for the field, Andrew Ng. Andrew Ng, then the chief of the Human Brain Project at Google. Now he is, I think, at Baidu in China, leading the AI department. And in the late 2010s, here it is in 2017, he toured the world with a lecture or with presentations and talks that had titles such as AI is the new electricity. And I'm now quoting again from a presentation under that title by Andrew Ng. And in this time, so at the end of the 2010s, this leading AI entrepreneur and researcher in the industry, he would say things such as, yeah, you know, if you want to do an AI business, there is actually today only one scarce resource for doing so, and this is training data. Other resources that you need is, for instance, compute power, but that's available even as a service. Today you wouldn't even need to set up your own computing center anymore, because you can go for Amazon clouds, Google clouds, Microsoft clouds, and so on. So compute is available as a service. Algorithms and implementations are available as a service on the same clouds. The only thing that you unfortunately need to bring is data. And this is why training data is, as says Andrew Ng in 2017, and I tell you it's still true today and even truer, the scarce resource is training data. The thing that you need to secure in your business plan or whatever when you want to raise an AI business is how to obtain the data that we need to train the machine learning models. And in that talk, and I will give you the link to the talks in a second. It is actually the reading for the discussion groups for next week, so you will be confronted with these 2 videos anyway. In this presentation, he also has a very interesting statement on the limitations of AI. Yeah, there are AI entrepreneurs that talk about limitations and not only about growth and exponential, we're all gonna get crazy. At least in 2017, that was still possible. And he says something like, anything a typical human can do in less than or equal to 1 second of thought, we can probably now or soon automate via AI. Okay, what is a typical human being? Maybe we exclude that very, very ableist perspective and question for the second. What he says is that we cannot expect AI to automate stuff that takes a human more than 1 second of thought. In 2017, no ChatGPT and so on. That is very interesting as a perspective. Keep that in mind for a second. He also has a nice business lecture part in this talk, and something he calls the virtuous circle of AI, which is, I think, an allusion to a vicious circle. He says if you want to bootstrap an AI business, like if you have a startup idea or whatever, you actually need to get into a self-amplifying feedback loop. And that self-amplifying feedback loop goes something like this. You build a product, and that product needs to attract users. So it needs to be a great product, or at least a great idea, or at least a great promise, or a great front end with no promise in the background. Doesn't matter, but you need to attract users. And these users need to be made to produce data. That's vital in the bootstrapping process, because if you have the data, then you can start training the AI system that you actually already sold to the users, but did not really have. But you can use the data from the users to improve or train that AI system so the product gets better, and the better product attracts more users, and more users create more data, and more data enables you to calibrate your AI system even better, and you need to get into that vortex. That's the lesson. That's what we can observe in the world about so many AI systems. There are even stories where AI services would start with click workers at the back end doing the AI work. For instance, there was this, like in the same year, there was this AI service promising to automatically sort your Google inbox, and a Guardian journalist found out they don't have AI, they just have click workers that would kind of sort your inbox. And that is the same idea. In the beginning, maybe you have click workers in the back end. The idea is that you can record all the things they do and then train AI and then improve the system, or automate more and so on. It's important to have that in mind when you talk about AI in society, because that is the mindset. Here are the 2 links to the talks, and it is, if you are watching this in the recording, I can even encourage you to, you might pause the recording now and watch these 2 brilliant videos by Luis von Ahn and by Andrew Ng for the context. If you are here now or live streaming now, you can watch it afterwards. It's fun. The thing I want to deliver to you or suggest to you is that the emergence of AI in its current form, yeah, we are talking about this 3rd summer of AI technology, yeah, a current wave of success that is beyond the successes that AI technology previously made in the 20th century and so on. The thing is that all this wouldn't be possible without the emergence of data collection infrastructure in our societies. Yeah, we would not be sitting here. This professorship wouldn't be here. Probably the courses you will be taking wouldn't be there if this didn't happen as kind of a prerequisite to the emergence of deep learning, machine learning technologies in the 2010s. After Google search emerged in the late 90s. I will talk about Google search in a minute. But then came the crash of the dot-com bubble. I don't know if you're aware of that, but in 2001, the first like stock market hype of the Silicon Valley burst, and many companies went bankrupt, and only a few companies survived and emerged from that crash. And it was companies that understood early on to capitalize on the Web 2.0 principle. And the Web 2.0 principle is that idea that in the web you don't only access websites that deliver content to you, but that you record user information from single clicks to where they are on the website to user-generated content such as text or images. For instance, Amazon survived the .com bubble crash because they always had these kind of user reviews of books or items that you bought. Yeah, because they had this kind of user rating feature where users could contribute reviews. That was kind of the distinguishing aspect from other bookshops online. And that is why Amazon actually emerged as the winner by far from this crash in the early 2000s. So the Web 2.0 principle was, and all the technological frameworks around Web 2.0, yeah, Ajax and the responsive design and all the ways of collecting data, even PHP and so on, that emerged in the early 2000s. The ESP game is a very early example of making use of Web 2.0 technology. And Facebook, where is it? Yeah, social media, Facebook and Twitter, they emerged in the middle of the 2000s. And Google Analytics, we'll be talking about that as well, and Amazon Mechanical Turk are from the same years. And this is the infrastructure that kind of spread worldwide, and not only in terms of geography worldwide, but in terms of it is in our habits. Like, we use it every day. We contribute to these infrastructures with our data every day, and not only we, but billions of people on Earth. And this is the prerequisite for sufficiently huge data sets to be accumulated, to be able to get something like a breakthrough of deep learning technology, which came with a latency of, sorry, it's hard to read, but it says 2016 and following years here. It's 2016. Yeah, so with about 10 years delay, much data-driven AI kind of skyrocketed after the emergence of this kind of worldwide data accumulation infrastructure. The current success of AI is based on the emergence of social media and Internet of Things technology. So what then is human-aided AI? This is actually what I wanted to tell you here. And the human-aided AI is a research paradigm or a philosophical paradigm of looking at AI, and it rests on 3 pillars or 3 theses. Thesis number 1 is this: most commercial AI systems today are actually hybrid human and silicon-based computing networks. This is actually an invitation to question these systems for this very feature. Let's look at the very simple example, Google Search. Google Search is an AI system, and not even at the end of the 90s when it emerged, it wasn't even like a simulated neural network. But you would imagine that you access an AI system when you use Google Search. You type in a keyword and then it gives you the result. The thing is, I'm not sure if you are aware, but if you click on the links, it looks like this. This is what the links look like. Yeah, you think you get to Tagesschau when you click Tagesschau, the search result tagesschau.de, but where you actually get is this. Get back to Google. And not only you, but a list of parameters gets back to Google when you click that search result. So you access a Google server when you click that search result, and the Google server would actually very quickly redirect you to tagesschau.de using HTTP 301 or something, redirect mechanisms. So Google is registering your click. on the search result. Here, I think this is the same. It's the same link, but it's interesting to see what happens. Sorry, now I lost track. So this is what you call, but if you look at the source code from the search result page, initially it looks more like this. So initially, like when you load the search result page, tagesschau.de is actually the target of the link, but there is this JavaScript in here, a JavaScript function on mouse down. So something happens when you press the mouse button down on the search result, and what happens is that a function called RWT is being called. RWT, what is that supposed to mean? It means rewrite. And it rewrites the target attribute of the link. Yeah, the moment you press down the mouse button, the target attribute of the link gets rewritten. And what it gets rewritten is this. Yeah, so you don't even notice. If you use the hover, if you hover the mouse over the search result link, then it says tagesschau.de in the status bar as the link target. If you visited tagesschau.de earlier, the link has another color, and all this works. But the moment you press down the mouse button, the target gets rewritten, and the link is called only when you release the mouse button, right? I'm not sure how much you are into web program, but this is how it goes. The link gets called the moment you release the mouse button, but the rewrite happens when you press it down. So you call that link. And that link contains a ton of tracking parameters. If you do some reverse engineering, which we did here, you can refer to that paper. It has a lot of information about you. And we will not go into all the details here, but what's very important is, for instance, is this actually the first search result that you had a look at? Was this the first thing that you clicked, or did you click a result and maybe didn't like it, and then you used the back button, or you switched the tab back to the result list, and then you chose another search result? That is very important for Google to know. Why is that important for Google to know? Because that tells something about the quality of the previous search result. Yeah, if this is the second result that you click, then you were not satisfied or potentially not satisfied with the previous result. And this is something that Google wants to know to train the AI system. So the data that is being collected upon, like what you click, which result you choose from the list of 10, and at what time, like if you choose different ones, that is relevant information for that AI system to constantly get retrained to come up with relevant search results. How else would an AI system be able to know what is today, on the 15th of April, the hottest search result for a specific topic? I mean, there are new topics every hour on this globe, and not everything is similarly relevant. The AI system somehow needs to know what is now relevant, and it learns this from the users, from you using the system. So it constantly collects data from the users and gets retrained on that data, and it gives data back. And would you cut off the data collection, probably the search result quality would go down like this over time, and even within a couple of hours, you would notice. So it is kind of a swarm principle, if you like. But the decisive thing here is that the intelligence of that AI system, it's not only in the server centers and in the algorithms, but it's actually something that is in the design of a feedback loop. Yeah? AI systems always rely on the design of a feedback loop between the output and the system. Yeah, the system wants to know, how well was my output? How good was my prediction? How relevant was this? When you use voice type, you speak and the thing types, maybe you correct it, and that is feedback. And so the story goes for almost all kinds of AI, that it is about the design of feedback loops. It's a cybernetic principle. You call that science of feedback loop cybernetics. It comes from the 1950s or 40s. We will hear something about that in the lecture as well. But think about it that way, that locating the AI of the Google Search AI in the server center would kind of fall short of this pressing observation that apparently we all contribute to that intelligence, and it's a huge crowd intelligence mediated through the interface, right, the search page and the infrastructure in the back end. Yeah, that leads me to actually the second thesis of the human-aided AI paradigm. I call it the correspondence principle. Machine learning problems today are translated into the design of human-machine interaction. The design is optimized to make or keep users available as training data producers. Free and often unrecognized labor. Yeah, another example if you're not yet convinced, let's continue with examples. I have tons of them, but let's bring one more. For instance, this here. This example is actually facial recognition AI systems. The company Meta, at that time it was still called Facebook, so I say Facebook in this lecture. Facebook built one of the first facial recognition AI systems, DeepFace, in the 2010s. And DeepFace, it was actually a project that took them some years. And the idea for that came up even in the 2000s. And they knew very well, what do we need if we want to use machine learning for facial recognition? It's kind of similar to Luis von Ahn's ESP game. We need a huge database of labeled face images. If you want to train a facial recognition system, we need millions of face images where we know who it is on the image. The question is how to obtain that. Maybe the question is not even how to obtain it, but who is in the position to obtain these images. And apparently social media companies are in a very good position to obtain millions of labeled facial images for free. And this is how the idea came up at the end of the 2000s to introduce this feature, face tagging. Yeah, Facebook introduced the face tagging feature, yeah, that you can tag someone on an uploaded image. At some point, I forgot the year, I think it was 2009, not to ease you in sorting your family albums, although this was how it was sold to the users, that they have more handy image archives if they label the people on the images, because then they can more easily find Paul in the image database. No, that was not immediately the interest of Facebook. The interest of Facebook was to get labeled facial images to train an AI system, but they didn't tell the public. Problem is, users really didn't like labeling using this feature. It turned out, you can read the research papers. There were papers in that time about this. And the thing is that they discovered that the compliance, so the fraction of users actually doing it, was too low. And so the idea was, or the question was, how can we actually improve the likelihood that a user would label the people on the uploaded image? And one of the ideas was to come up with such a drop-down list. Yeah, the first versions did not have a drop-down list. They had only a text box where you could type the name or the profile handle or whatever. And then the idea was, maybe we can come up with a drop-down list. Then it is only one click. And demanding only one click from the user increases the likelihood that the user will provide that information compared to when the user has to type the handle of the person. How do you come up with a drop-down list? Okay, you could use the friends of the user. You could just alphabetically print all the friends of the user in the drop-down list. I'm not sure this helps, but imagine you have a half-accurate or half-trained facial recognition AI system, a facial recognition AI system that comes with maybe 50% accuracy or 30% accuracy. You can use that AI system to produce a drop-down list. You cannot use it to recognize somebody, but you can definitely use it to produce a weighted drop-down list. Yeah, you would use all the Facebook friends of the user and run it through the system, and you would print the people with the highest probability top, And so you produce a drop-down list. So you use the AI system, which is half accurate. It cannot walk the last meters on its own, but you use it to approach the user in a way that makes it easier for the user, or more probable for the user, behaviorally speaking, to provide the missing data through one click. You see how user behavior and AI system get kind of converge with this very clever user experience design. And you see how it is done through user experience design. Yeah? Building that AI system was only half a programming job, and the other half was a UX design job, coming up with such ideas. And then in the 2000s, I forgot the exact year, I think it was 2017 or something, the system became more accurate. Let's say, I don't know exactly, 95 or 98%, or maybe they didn't even publish it, would be typical. But it became so accurate that Facebook could use the system to more or less accurately recognize people. And then they would roll out a next stage of the product. And the next stage was this. They suddenly started, it was in 2017. They started touting the facial recognition system as a privacy feature. Thing is, okay, a little excursion. Historically, they denied that they use the user-labeled face images for AI training. Then they had some customer rights organizations in the US suing them to stop doing it and to disclosing that they do use it for AI. And at a certain point, when they could no longer deny it, they kind of switched strategy to the opposite and said, yes, we built AI system to recognize images, but it is for your privacy. And this is where we are now. So they switched strategy and said, we are using it for your privacy because when somebody uploads an image and does not label you, and it is an image of you, then you get an alert. And this looks like this. So they kind of sold it to the user as a feature to get alerted when anybody on Facebook would upload an image, and the AI system recognizes that user on the image. And it looks like this. You get this pop-up here. Kevin Burton added a photo you might be in. And then you can say, yeah, but please ignore me. Or, yes, please tag myself. That's what you can choose. If you go in the three-dot menu here, you have another option. It is this one here, not me. You can say, sorry, it's not me. Nice AI system, but that was not me. Why? The thing is, for Facebook, what matters is the difference between this here and one of these, right? Because that is the information that the prediction was wrong, or the detection was wrong, and that is the information that it was correct. And that data is being used to train the AI system. So even though a facial recognition AI system has 90-something% accuracy, it will never be finished training because people grow older, people have other haircuts, people have new whatever. You will need a constant stream of verification data, information on whether a certain classification was correct or incorrect. You need a constant stream of that data to constantly retrain the AI system to keep it at a certain level of accuracy. Otherwise, if you cut off that feedback data, the accuracy would go down over time, even within a couple of weeks. So that is the next very nice UX stunt to actually produce this stream of verification data without the user even being aware that they are, through choosing from one of these options, part of an AI system. Yeah, I would say the users are part of that AI system because the user provide a little piece of computational or cognitive labor or cognitive contribution, verifying or disverifying this AI system. So this is the general idea, that it is kind of a sport. the sport in this lecture is to look at any AI system and question it for hidden harnessing of human cognitive skills as an essential part of the AI system, without which it wouldn't be working. And if you look into this more closely, there are actually different strategies of capturing human cognitive skills. I will list, here's a list that's it's not a complete list, yeah? Maybe there are new strategies now. That goes back to research I did 5 years ago. But at that time, I saw at least 4 different strategies. The one was gamification. Gamification, for instance, the ESP game, yeah, was the idea of turning the AI problem into a computer game. But other gamification examples, for instance, is this here, Pokemon Go. It's a very nice example of turning users into cognitive subunits of an AI system. Why? Because this is a very nice way of obtaining geolocation data, right? The user is the agent in the world, photographing a certain monument or street corner or house from various angles as you see fit, as the AI system needs. And so the Pokemon Go can aggregate multi-perspective visual data of literally any corner on Earth that they do use for the training of AI services. Another strategy I call trapping and tracking. Sorry, it's a little bit a clumsy name. But trapping and tracking, the prime example is that. We know it all, right? ReCAPTCHAs, like a barrier on the web where you have to prove that you are a human. So that you have to prove that you can do cognitive labor that a machine cannot do. As you probably know, these things are also used to train AI systems. Yeah, for instance, here, that is from Google Street View, and they weren't able to kind of transcribe or recognize this sign here. I don't know what was the problem. I can't even imagine. But this is being used. This is actually a nice little moment when you contribute a piece of cognitive labor that takes less than 1 second of thought of the typical human TM to an AI system. Nice principle. Do you know who invented it? This is the original research paper from 2003 by Louis von Ahn. It's one of his other sub-projects of his PhD. That he is actually a co-inventor of the CAPTCHA principle. The CAPTCHA, which were called using hard AI problems for security. Mind the paper title, using hard AI problems for security. So for AI systems at 2003, this is a hard problem. This here is a hard problem. So you can use it as a security barrier, filtering out robots. But at the same time, if you are the platform company who is in the position to provide all these CAPTCHA images on millions of websites out there, you can recognize or register the human answers to these things and train your AI systems with it. So if you are the service providing the CAPTCHA, you will probably have the AI system that has its head. How do you say that? The best AI system, yeah? The AI system that is better than the others because you have the training data on these images. And the CAPTCHA principle has been turned into reCAPTCHA, which is the explicit idea of making use of it for the training of AI systems. In 2008, a company co-founded by Louis von Ahn. Yeah, was the idea here. reCAPTCHA originally started by the idea of transcribing historical manuscripts from libraries. Yeah, so manuscripts like books would get scanned, and then you need OCR, like character recognition, and sometimes it doesn't work. And in these CAPTCHAs of that time, you would have 2 parts. This part is where the machine already knows the answer. So with this part, they verify that you are a human, and with this part, the machine learns something new. Problem is, that gets switched randomly, so you don't know whether you have to be right on this one or on this one. So you will have to be accurate on both. And so from the one part, the machine learns something and trains their own AI system, and from the other half, they verify that you are a human, and if you aren't, they would discard the training data, of course. Harnessing social motivations is another strategy of harnessing cognitive skills of humans for AI. Facebook photo tagging is the best example. That is, of course, a social driver. Yeah, you are socially incentivized to upload images. This is a part of our everyday communication nowadays. So you are kind of hooked by your social needs, and by just following them, you contribute to AI. There are many, many more examples for that. One of my favorite because little known example is this, using emotions or reactions, because that isn't this the easiest way of providing your emotions in a machine readable form? These like tableaus of emojis are the best interface to nudge users into machine readable codification of their own emotions or emotional reaction. And if there are reactions, like if there is something like this, the machine is able to even feel or learn how the emotional or affective dynamics unfold from certain contents. Another example is click work, and this is actually a major example where it gets outright exploitative, if you will. And this is also something that few people are aware of, that much of AI does not only rely on harnessing the data that we users in comparatively privileged societies produce every day, but they harness also data that gets produced by humans from economic rationalities, usually in societies with lower wage standards, often in the global south. What I mean is these click work farms where annotation work, data cleaning work, content moderation work, and so on gets outsourced by Silicon Valley and other IT companies, as I said, usually to countries with a way lower wage level, because it needs these human agents to make certain classifications, annotations, decisions, and so on. And one of the most cynical examples of click work that are an integral part of the history of modern machine learning is Amazon Mechanical Turk, which, if you remember the timeline slide, emerged in 2000. Was it 4? Was it 3? I don't remember, but in the early 2000s. It is a service by Amazon where you can register as a click worker from anywhere on Earth. You can, for instance, do it on your mobile phone or on your desktop computer. So you can register as a click worker. You can also register as somebody who wants click work to be done for them. This is maybe a perspective that you know if you are at the Coxie Institute, because many research institutions, including the Institute of Cognitive Science, in research projects regularly make actually use of these services for annotation, data cleaning and annotation purposes. The idea is that Amazon Mechanical Turk is a platform that provides an API access to human cognitive skills. For instance, here I came up with an example. Let's say we want to have a list of sightseeing items in Berlin, and we do that with Amazon Mechanical Turk. Then we can actually program, we can actually provide code that accesses the Amazon Mechanical Turk API that in turn triggers human beings to provide computational labor that you, once the routines stop, will be able to source through the API and include in your computational processes. So here it creates what's fun to see in Berlin ideas so far. So it creates a question, and then the question gets pushed to some click worker. The click worker answers the question, and then there's a sorting function where click workers are used to rate whether which of the two ideas are better. So you get like a weighted list of sightseeings in Berlin using Amazon Mechanical Turk. So the idea here is that we want to do computing like this. You are probably more like this one here. Like not by your background, which I don't know, and which has a certain diversity here in the room, but now that you are studying cognitive science, and here as a university student, probably at some point engaging in research or technology development, you are probably most likely in this position here, where you have certain problems, for instance, AI problems to solve, and you create code, and that code gets executed not only on computers or on silicon-based processing units, no, but also on brains. And there are these services such as Amazon Mechanical Turk that allow you to run code on human brains. And this kind of remarkable cynicism, if you will, has been part of the development of AI from day zero, because Amazon Mechanical Turk was actually first on the market before nice machine learning networks were out there. I will skip the next slide for those following the PDF notes because it's not so important right now. So what I want to bring to you by these remarks is that AI technology is deeply entangled with structures of extractivism. AI technology comes with extraction of many things. Yeah, AI extractivism is actually the technical term that's being used by some in the research discourse for this. And I put some books here making this case. AI relies on the extraction of energy worldwide, and huge amounts of energy, for instance, for the training and use of neural networks. It relies on the extraction of materials like rare earths and so on to build the computer chips and so on. But it also relies on the extraction of labor and data. Labor and data are resources that are vital to AI systems today, or let's say to AI socio-technical systems. There is no AI that is not a socio-technical system. And you need the data, otherwise you will not do this kind of AI. And this brings me, I put these two here in red because in this lecture we will more highlight these two aspects because we are talking about societal impact, although that is also linked to societal impact. But as the discourse in research more highlights these aspects, I chose to highlight more these aspects here for a slight counterbalance. This brings me to the third and last thesis of the human-aided AI perspective. AI leverages different forms of power gradients to turn humans into subcomponents of large-scale distributed computing networks. Yeah, I mean, you always have to ask the question, why would human beings do that? Why would I provide my data, my cognitive skills, whatever to the AI system? And at any point where cognitive skills or data is being provided, there is some form of a deal or power gradient or enforcement mechanism or even outright exploitation governing this flow of information, data, cognitive labor, and so on. And this you can envision as a power gradient. Yeah, without a power gradient, no information will flow in that direction. So AI makes use of power gradients. The four capturing or harnessing strategies I listed earlier, they are basically for different kinds of power gradients, if you will. And it's important to know that the spectrum really runs from things that can be very hard, very physical, but to things that go almost unnoticed. Yeah, why is this concept of AI useful? Basically, that is a question that will be answered throughout the next weeks. But just as one heuristic argument, as you see, when we access AI on our devices or whatever, this is only a very limited scope of the story. First of all, we are all doing it. And second of all, this is all interconnected so that we are enmeshed in these AI networks through the devices that we and services that we use every day. And the thing is that AI systems do not only extract data from us and learn something from us through this entanglement or enmeshing in information networks, but they can also give something back to us. And what they can give back to us is not only search results or the output of ChatGPT, but it can also be something like that we get classified, or that we get different chances, that we see different information, that we get manipulated, and so on. So an AI system that, or AI systems that rely on the deep entanglement of so many users are equally able to actually make differences between the users. Yeah, to treat us differently, to predict information about us based on which we are being treated differently, and so on. This is basically the scheme, that we created a socio-technical infrastructure that is not only extractive in the one direction, but that will have the capacity to do justice or injustice to any of us by making differences between people. And as I will try to tell you, the differences AI makes between people are structural differences. So not only individual ones, but really structural differences that, for instance, easily perpetuate racism, classism, forms of exploitation that are of societal import. And that will lead in the lecture to the analysis of AI technology as a power technology. Yeah, there is no ethics of AI without analyzing power relationships. And this power, and this is my last slide, don't worry, will be power that can be manipulative, discriminative, or even exploitative. That is basically what we will be doing. And we can actually close at this point. I had one more slide, but I will start in the next session with the next slide. That's not a problem. I just had one slide on the lecture overview, but I will better tell you next time. So thank you very much, and see you next week. Don't forget to register for the discussion groups if you like on Thursday morning.